organization. Would someone be kind enough to average these 6 numbers? Pretty sure it's going to be 18 point something.
I got 18.15.
18.15. Anyone else? You got something different, Emily?
No, that was 18.
Same thing? Okay. So, seconds. So my period, that's for 20 revolutions. My period is for 1. So I divide this by 20. So if I do my 18.15 divided by 20, I will get the period, the time it takes to do just one of those. So doing the fancy math here, this becomes 0.9075. Thinking that's right. Ooh, we're going to come out closer than I expected. All right. So what does this end up being?
.501.
No, it can't be. 5 point something, but not
I got
0 point.
5.02.
5.02. That makes more sense, because this is 6 something, and then I'm multiplying by something a little less than 1, so it shouldn't be less. So we figured that it should be 5.7 meters per second, and we got 5.0 meters per second. That's better than I've ever done before on this. Or your timing was better than students usually are. All right, questions? All right. The lab is going to be doing something similar to this. There will be a graph in the lab. You'll do the timing. You basically are going to, what you're doing in the lab is predicting what the mass of the stopper is. You'll know what the actual mass is, but you'll, through a more complex mechanism than just putting on triple beam balance, you'll try to see how close you get. Unfortunately, the 25–40% error is not unusual. If you are 100% off, then usually there's a math error. Sometimes it's just, there's a measurement error, but by the time I see it, it's too late for that. So just be careful. I do want to point out that there were 2 forces acting on the stopper. There is the tension pulling it in, well, actually part of the tension pulling it in, because we are pretending that that stopper was in the string were horizontal, but it actually sagged a little bit. So if it sags and is going around this circle right here, I had tension acting this way, and I have weight acting down. It's only the horizontal part of the tension, which is the centripetal force. It's only part of it. And for 151 and 251, physics 151 and 251, they take the angle into account. However, they get the exact same answer that you would get if we made the assumptions that we're making. So you're still going to get the right answer, but I just want to acknowledge the fact that the tension is not horizontal, but you still end up with the same answer. I would say, well, first, any more questions? Then let's adjourn to the other room.